In my next video, we're talking about serverless without the lock-in. Stay tuned to learn how you can migrate from AWS Lambda to OCI functions, taking advantage of the open source FN project to create serverless functions that run anywhere. You have a look at the architecture and design for this particular setup. We have an S3 bucket. Now, some process is going to drop an image into the bucket's input folder. From there, a Lambda function is going to trigger. It will read the input file and write the output into the output folder. From there, some other process is going to pick up that image and do some downstream processing with it. Now, the Lambda function is going to be written in .NET. The goal here is to take as much of this Lambda function and port it directly to OCI. We want to preserve the business logic and only replace the integrations with AWS. Now, obviously, the business logic required to create a thumbnail from an image is pretty light. But if we expand upon this to take into account the other business functions, we can start to build out a reusable pattern for porting our Lambda functions. This pattern of processing files as they're dropped into S3 is actually very common. Oftentimes, data files are handled this way to do pre-processing. Maybe you're sanity checking. You might want to take in a file as CSV or XML and then transform it into JSON. Or maybe you need to enrich the data before the file gets processed downstream. The possibilities are endless. Okay, let's jump into the code. Okay, so I'm here in Visual Studio, and we're looking at the function that was set up to handle the S3 event. Now, I've got two files here. One is function.cs. This actually gets created by the SDK when I set up a new Lambda function, and you fill in a bunch of your details there. A lot of this is going to be the boilerplate code, for example, Lambda serializer, public class function, which just sets up the object that's going to be called, and the function handler. Now, this is the entry point that Lambda will invoke once the event takes place. And so what we do is we grab the event records. Now, in theory, some invocations for Lambda could handle multiple records coming in at once. In this case, we get one invocation per file that's dropped. So it's never really going to be more than one, but we always handle it that way just in case. We're going to grab the response and log it. That's just standard behavior. It comes actually in the boilerplate code. And then from that response, we're going to grab the bucket name and the object key, equivalent to the file name, from Lambda. We're going to do a get object, which will go to Lambda and actually open up a stream that allows us to grab the data from the file sitting in Lambda. And then we're going to process that. So we're going to grab the data from Lambda. We're going to copy it into a memory stream. And then we're going to call this image processor function to process the image. This is the business logic. Everything else here in this class is really just boilerplate AWS integration code that says how is Lambda going to function and how do we interact with S3. Once the business logic has happened, we process the image, we get back the output. We're then going to write that back to S3. Now this is the business logic. Keep in mind that your business logic should always be separate from your integration code. The stuff that interacts with Lambda should be kept separate from that. It's because that enables you to take this code and use it in multiple different scenarios. Maybe it's a Lambda invocation. Maybe it's something else. Maybe it's an on-demand process. Or in this case, maybe it's code that we want to shift over to OCI. So we're going to preserve this function here, which contains all of our actual valuable business logic without having to carry over the code for AWS. Now, we're going to jump into the AWS console. We're going to see how this all works. Okay, over in the AWS console, I've opened up the Lambda service, and I'm having a look at my thumbnail generator function. Now, I'm sure if you have used AWS Lambda functions in the past, you're familiar with this. This here is my actual function. I've uploaded the code and published this to Lambda. And here's my S3 trigger. And what that does is it defines the properties. You can see here, it's going to fire on S3 object created. It's going to look at the input prefix. So this is what I was talking about before, making sure you have different prefixes for where your input files are and your output files go. And some other details around accounts and things of that nature. Now over here in S3, this is the location that maps. And what I can do is I can take a image file, I'm going to drop it here and upload it. We go upload. Have a look. There's the image. It's an image I took of myself. And if we go and we look at the output file, you'll find that a very similar image was generated by the Lambda function. It looks the same, it's just a lot smaller because it's a thumbnail. Okay, so you can see we've got the code. It works. It works as a Lambda function. It responds to the trigger. So now we got to look at how we can move that over to OCI without changing the business logic. First thing we want to do is have a look at the code for the new OCI function. Now, I did a 3-part series on getting started with OCI functions in .NET over on basementprogrammer.com. That covers everything you need to know about getting your development environment set up so that you can create and publish .NET functions on the OCI platform. I'm not going to cover that material in this video. I'm going to assume that you've already had a look at that and your development environment is ready to go. Okay, now the first thing I want to show here is the image processor. This is our core business logic. Now, all I've done is literally just copied this file over from the Lambda project to the OCI project, and I changed the namespace just to make it easy. Copying your source code file is probably not the most efficient way to manage source code, but it was just easy for this sample project. You probably want to consider something a little bit better, like sharing the file across, or maybe building a DLL and incorporating that into both projects so you're not maintaining 2 copies of the source file. But for the purposes of this example, copying it was very simple. Now, like I said, the business logic has remained unchanged here from the Lambda function. we accept an image in the form of a memory stream. You can see it coming in here. We then do the processing on it and then send it back to the caller. This is the core of what makes it possible to migrate your Lambda function over to an OCI function, keeping the business logic away from the platform code. Next thing I'm going to do here is dive into the actual platform code. So this is what ties into the OCI functions and allows you to run a serverless application. Much like a Lambda function, we've got a handler. In this case, it's just called greet. That's only because I use the sample project. If you use fn init, it's going to create you a sample project, and it's going to have a function called greet that accepts a string, which is your input. Now this input here is the JSON string that represents your event. So much like the Lambda project, the OCI default functions don't deserialize it into a strongly typed class for you, so you've got to do that yourself. But other than that, you're getting that data. Getting that data element passed in here as string. So what we do is we're going to parse that input string into a dynamic object. That's the source. And you can see here I'm going to grab and write out some of the details we're getting. So where is the bucket? The location that the file is dropped. What is the resource name? That's actually the name of the file. And I grabbed the resource ID here. We're going to get a provider, and this is basically the way to get some credentials. Now, this is a resource principal authentication provider. It's the way to not have to code in usernames and passwords. Now, if you're familiar with Lambda, it's equivalent of like a role. In this case, it's a resource principal. So we're going to get that provider and store that. That's what we're going to use to authenticate to the services. Create a cancellation token. We just use that for the API call. And a very similar programming methodology here. We're going to create a request, which is going to be the get object request. So we're going to grab the details, the bucket name, the resource name, and the namespace, which helps us find where that file has been located. We're going to process in the very same way that we did with the Lambda function. We're going to have an image that gets dropped into an OCI bucket. There's going to be some code that then triggers this OCI function, and we get the details. So we do an object request to grab the object out of the bucket. We're then going to do a get on that. And providing that we get a response back that's not null, we're going to retrieve the object as part of this code. And I've also set up the put request, which is going to be the thing that writes the new object down back into the OCI bucket. So you can see here, we copy the object from the get request into a memory buffer. We call the image processor, same as we did for OCI. We pass in that buffer, that memory, the memory buffer that contains the image, allow it to do its thing, and then we're going to put that into the body of this put object request that I created up here, and then send that back down as an object. So the code is very similar to how Lambda works. You've got a big JSON object. You get the details from that object. You then retrieve the image from object storage, do our processing, write it back. And we've got some basic lines. We've got some basic code here to do some logging messages, things of that nature. So the code looks very similar. All we've done is change the way we're interacting. We're obviously going to OCI rather than AWS. Our business logic is the same. So now what we need to do is actually wire up the the function into our OCI account so we can be ready to launch this. Now let's have a look at deploying the function code into your OCI account. So first up, we're going to use the fn command line to deploy the function into OCI. And then we're going to have a look at the configuration required to hook things up inside your account and make it all work. All right, so now I'm back inside of my OCI account, and I'm going to use the fn command line to deploy the function into my OCI account. Now, I already have some infrastructure set up, so I'm going to have a look at that and show you what's been done as I get ready to do this. So fn deploy, and I want to do app. And now what I need to do is tell it what application I am pushing to in my OCI account. So you can see here applications that I have. I've got an application called dev functions. So there I go. I'm going to copy that and paste. Now, what this is going to do is behind the scenes, it's going to go and it's going to build the project. In this case, it's a .NET project. And then it's going to package that up as a Docker container and upload that into the container repository that I have set up in my account specifically for this project. Now, I'm going to wait for this to complete, and then we're going to actually dive into the account and have a look at things. So there we go. You can see we've updated the function thumbnail function using the latest image that I've got there. All right. So if you read the blog posts that I did about setting things up, you know that OCI has collections of serverless functions called applications, and then applications have a number of different functions inside of them. So you can see here, dev functions is my application. And I've got this one function here, thumbnail function that I've created and published out to my account. Now, all that is going to do is have a function sitting there. I have a bunch of things that I need to do in order to make this all work. First off, I need a container registry. Now, what I've done is I've got this set up here, and I pre-created that in my account, and that's where all my images are being sent. You can see here it's got 29 images. Obviously, I've done a lot of development and test pushing and things of that nature. So that's the repository where my container gets published. And then my function that is part of my application draws from that. Now, that's all well and good, but in order to actually do something, my container or my function has to have permissions to access various resources. In this case, object storage. So if you think about, if you're an AWS programmer, for example, which is what you probably were doing to have this Lambda function, you would create a role. Things work slightly differently inside of OCI. So the first thing you want to do is create what's called a dynamic group inside of your default domain. Now, the dynamic group, effectively, you create a matching condition, and everything in your account that matches that becomes part of this dynamic group. So what I've done here is I've created a dynamic group, and I've said that all functions, see there, resource type function, inside of my compartment ID, just sitting here, become part of this part of this function. Now, the compartment that I have is actually a compartment that I've defined specifically for function development. You can get very granular here. What I've done is I've said everything inside of this one compartment. You can also start matching on things like tags. You could also match on a specific function if you wanted to. Probably not the most useful to create a dynamic group for that function, but certainly something that you can do. Okay, so first thing you've got to do is create this dynamic group and provide it with a way to find your function. So again, in this case, all internal functions or all functions as service functions in that container. The next thing you have to do is set up a policy. So the dynamic group is your entity that you're going to map to. Policies is actually going to grant you permissions. So what I've got here is, again, in my container specifically for my functions, you can see your compartment functions development, I've created a policy. Now, policy is going to say allow dynamic group functions in functions development, which is that dynamic group I created, to manage, and I've been very broad in my permissions here. I've just said you can manage all object family. So that's going to give things like objects, buckets, etc. in compartment functions. Now the two of these combined, the dynamic group and the policy, are going to allow my function to then access objects and object storage. If you remember, when we're setting this up, we've got images being dropped in an object storage bucket. So this gives permissions to my function to actually access those objects. Now that I have my function deployed, let's look at how I can trigger that function. Over in object storage, I have a bucket created and a folder in that bucket called input. Now, one of the things I really like about OCI object storage is that bucket names are unique within the compartment. This way, you don't have to have globally unique bucket names from everybody else in the world. Buckets can have names that make sense inside of your workload, and they get separated out by compartments. Now, the logic here is that the image is going to be dropped into the bucket in the input folder. Then we'll trigger an event to do the actual processing by way of that function. The function's then going to drop the file back into the root drive or the root folder of that bucket. Keep in mind, you don't ever want to drop the output file back into the input location, because that's going to cause a tight loop and you're just going to keep reprocessing and potentially creating a really big bill. So, just like Lambda, always make sure you're dropping your output file into a different location or a different prefix or folder in the bucket. All right, let's have a look. Okay, so inside of my OCI account, you can see I'm in the compartment that I've been working in, functions development, and I've got the function bucket here. And inside of that, you can see I've got the input folder. So that sets up the storage locations that I need. The next thing I want to do is I want to look at rules. Now, rules you can find here in Application Integration Event Service Rules. I've got a rule that I call trigger function I've set up. As normal, you need a display name and a description. And I've got rule conditions. The rule condition is going to be for event type and service name is object storage. I want to look for the create and update events. Now that's going to happen inside of my compartment. And I have a further condition that says the resource name has to start with input /* So there's a wildcard. So anything that starts off with that input first part to the name is going to trigger. Now you can see here, you've got the rule conditions builder here, which is nice. It lets you, graphically build that out. But then you can see here the rule logic, or what it actually creates as JSON. You validate it. Now, I can get very specific with lots of conditions about how I want to do this. I've left it pretty open so that we can make it work fairly easy. In production code, you probably want to tighten this up a bit more. The next thing is you've got your rule condition, which says when something gets dropped in an input in the input folder, what do I want to do? And I've got a very easy action here, I can just say functions, which is my action type. Look at my compartment, so functions development, and it's going to give me a predict. It's going to let me pick the application, dev functions, and the actual function that I've got. So it's very easy. I can just go and set it and pick it up. So when the rule condition logic is met, we're going to trigger the function that I've created and uploaded. Pretty simple. Again, you can get very complex with the rules and the logic, but not necessary for this quick demo that I'm doing here. Okay, now I would be remiss if I did a development project here and I didn't show you how to find the logs for your function. Now, logging for OCI functions is done very simply through like console.log. And obviously you can incorporate other logging techniques if you want to, but the console.log is going to go to the centralized logging that is baked into every function. You don't have to do anything. It's just going to be there. You do configure the log as to where you want it to go, but we'll have a look in the account real quick and I'll show you how to connect it and find where your logs are going. Okay, so here we are back in the OCI account, and I've gone into functions. Now, functions is in your developer services area. You go to applications here, and I've clicked into my dev functions application. Now, along the side here, you can see resources, and if you go down to logs, you can see the item here for logs. So category, function, invocation logs. And you can see here, log name. Now, when you set up a new application, this enable logging is actually going to be turned off by default. You do have to come in and turn it on. Once you've done that, you can go here and I'll go open a new tab. Once this loads, just take a minute. You'll be able to see the log group. Now, I don't have any log entries here for the past 5 minutes, but you can see it's going to be filtered here. And in a little bit, when we actually test the function, you'll actually see some log entries being generated. All right, so the last thing that remains is to actually test out the function that we have ported over from Lambda into OCI functions. So we're going to jump into my account and test it out. Okay, so now what we're going to do is jump into my account and actually test out the function and its execution. So you can see here I'm in the storage bucket location in my account. I can get there from going to the menu, storage, buckets, and then click into the bucket that I want. Make sure you have the compartment selected, which is where all your stuff is being set up. So I can go function bucket. And from there, I can see the objects area in the bucket. Now, all your objects just actually sit in the bucket. The idea of folders, much like the same in AWS, folders is really just prefixes. So that's the start of the name, and we filter it in the display to make it look a bit like a file system. So what I can do there is I go into input, I'm going to upload, and I'm going to upload an image that I have on my computer sitting here. It's just a image that I had for a presentation that I was doing. Click upload. Now that's going to upload fairly quickly. And you can see there the basement programmer image arrives. And now behind the scenes, what's going to happen is that event that has been triggered, or that event that has happened, is now going to trigger an event in the rules engine, which is going to fire off my function. If you're working in OCI and you discover that for some reason your events aren't firing, here's the thing you want to look at here, emit object events. Now this is off by default, and what that means is that every bucket in your account isn't going to be randomly generating events. You do have to turn this on in order to have events fired. So in order to have your code being triggered, you've got to go and enable this. Now, I had this enabled because my bucket was already set up and I was doing some development work. But if you find that you're not getting events firing, do check that. It's set on a bucket by bucket basis. Okay, I'm going to jump up here. And you can see in the short amount of time that I was talking about that emit object events, the function is fired, it's processed, and it's generated this output event. Now, again, I've put it in the root folder. I didn't want to put it inside the input prefix because that would have then triggered another iteration of the function that would have gone over and over and over again. Okay, so now what I can do, I'm just going to download this image. And you can see there, it's gone, it's been downloaded. And I've got a copy, and if we open it up, you can see the image that was generated, obviously quite small, as opposed to the original, which is larger, which is what you would expect from a thumbnail generation. We've got a smaller copy of the image. Now, one last thing that we should have a look at is your logs, because again, as you're developing, you're going to need to look at your logs to figure out what happened, what went wrong. I wish my code was perfect every time, but it obviously isn't. So when I go into the logging area, and the shortcut, the easiest way to get here is actually if you go into applications and you go to logs. So the dev functions is the application I'm working on now. You can click here to log name, and that's going to bring you directly to your functions logging. Now, let's see. You can see here some of the logs that were generated for my test invocations. This here was the last invocation that I made. And you can see this correlates to the log, to the console output write statements that I've created. You do get a few for free. For example, serve function invocation request in 2.330 seconds. That's how long your function was running for. Obviously, it ran quite quickly. And the rest of these things like namespace, resource ID, object, bucket, etc., those are going to be the log statements that I wrote out for my application. In fact, we jump into the code. Let's see, source program.cs. You'll see that those statements here are in my code. So you can view your function output in the logs without having to go and incorporate any logging frameworks or anything like that. You certainly can if you want to, and if you wanted to push all your logs out to another source, that's perfectly fine as well. Quick recap of what we've done in this video. We took a Lambda function that was running in my AWS account, and it was processing images as they arrived in a bucket. We created an OCI function to accomplish the same thing by rewriting just the AWS integration code to work with OCI, and left the business logic unchanged. We deployed the new OCI function using the FN serverless tools into my OCI account. We then set up the event triggers, a dynamic group, and an IAM policy to allow access to the OCI bucket. And we successfully ran the application. Now, just a reminder, there's a 3-part blog series on basementprogrammer.com that walks you through everything you need to know to get started with OCI functions. It's a good idea to follow that series before following this video, just to make sure you get everything set up and ready to go. Now, all the code for this video will be published to my GitHub account and made public. That includes both the Lambda code as well as the OCI code as well. Hope this helps. Complete source code for all of my videos can be found on GitHub. You can find me there at github.com/basementprogrammer. Thanks for watching my video. If you found this video helpful, please hit the subscribe button. It helps you to know when I have new content out, and it helps me to know I'm creating useful content for you. You can always find me at basementprogrammer.com, on Twitter, and the Basement Programmer podcast. Details listed here. If you have any comments on this video, or you just want to get in touch, you can always email me. The address is tom@basementprogrammer.com. And I'll see you next time.